Can you hear me? Can you hear me? Can you hear me? Can you hear me? Yes, then. Are you sure you can hear me?
Okay, welcome back. We lost some people. We were 38 and now we're 32. Some people have been lost. So we had the expansion for 3, 1 plus 3x to the power -1. And this is supposed to simplify to 3, 1 minus 3x plus 9x squared minus 27x cubed, then plus those dots. Okay. And then we get the expansion for 2, 1 minus 2x, the power -1, sorry. Ignore that, I was almost writing 1 over something. 2, then 1 minus 2x, the power -1. This one will give us 2 outside, then we have 1, then minus -1. You have to be careful with the signs. How do I do it? 1 plus -1. Okay, let me just clear it. So we're saying 2, 1 minus 2x to the power -1 is equal to 2. Then we have 1 plus n, which is -1. Then times -2x. Then we get to the next term, plus we have -1 times -1 minus 1 over 2 factorial, then -2x to the power 2, plus -1 times -1 minus 1, then -1 minus 2 over 3 factorial, -2x to the power 3, plus dot dot. That's where we are. When we simplify this, we are getting 2, 1 minus 2x to the power -1 is simply equal to 2, 1 plus 2x. You can see it clearly there. So 2, then 1 plus 2x, and then on the other one, we'll have negative times negative, we get positive, so it will be again positive. What are we supposed to get there? If I look at what's happening.
F4x.
Yeah, so get positive 4x squared. Then next one, we'll find ourselves getting, so we have -3 times -2, you get positive 6 times -1, you get Negative 6 over negative 6 over 6 you get, so you're getting a positive 8, huh? Positive 8x cubed, then that continues like that. That's what we have. Then now adding the 2, so we're saying we have 2 plus 4x, then plus 8x squared plus 16x cubed. While the other one is supposed to be 1 plus 3x, the power negative 1. Hello?
For the power x2, isn't it supposed to be negative 4x squared?
No, it's positive. You see, you have negative 2 in the brackets. So when you have negative 1 minus 1, you have negative 2. Times negative 1, you get positive 2. Then in negative 2x squared will give you positive 4x squared. It's supposed to be positive.
Thank you, madam.
Yeah. Okay, so then the other one will give you 3 minus 9x, then plus 27x squared, then minus 81x cubed. That's what we have. Then plus dot, dot, dot. This one also plus dot, dot, dot. Then we can add. When we add the 2, what are we getting? What do we get when we add the 2? In the notes, I think there's a typo somewhere. So when we add these ones, we have 2 plus 3. When you look at the constants, are we having a minus somewhere? No, we are not. Okay, so in the notes, there's a mistake. So when we combine these, we will have 2 plus 3, which will give us 5. Then the x's, that will be minus 5x. We are collecting like terms. Then there we'll have 35x squared. And here we'll have negative what? Negative 65, is it? X cubed plus dot, dot, dot. So that's the expansion when we combine the two. I just ran out of the space there. So that's the expansion. Let me write it properly. So I have, let me write it here because in the notes there's a mistake. Once I erase this, that's it. Okay, so we clear this. We are now saying that 1 plus 3x, the power negative 1, plus 1 minus 2x, the power negative 1, is finally equal to 5 minus 5x plus 35x squared minus 65x cubed. So that's the expansion we are looking for. So I've added the like terms. And then the second part wants us to find the range of values of x for which the expansion is valid. Okay, so what guided my going up to x to the power 3? Why did we go up to x to the power 3, not x to the power 4 or x to the power 2?
They said the first 4 terms, the first question.
Yes, so we wanted the first 4 terms, that's why we just had to go up to x to the power 3. Okay, good. Then validity. So you see 1 plus 3x to the power negative 1 is valid for absolute value of 3x less than 1. I think now we know how to go about this, and that will mean that absolute value of x is less than 1 over 3. Or we can say negative 1 over 3 less than x less than 1 over 3. Then the other one, 1 minus 2x to the power negative 1. This one is valid for absolute value of negative 2x less than 1, and that will give us absolute value of x less than half, or minus half less than x less than half. So then we want, these are the validities for each of the binomials. Now we want the set of values for which the sum of those binomials is valid. So it means that the values of x should satisfy both absolute value of x less than 1 over 3 and the absolute value of x less than half, meaning that we are getting the intersection set of the two sets. And what's that intersection set? So it's always easier for us when we sketch. So could have minus 1 over, which one will be at the far end? So we are saying we have 0 there. So we are getting negative half. Then we have negative 1/3 somewhere. Then we have 1/3. We have half. So when you look at the two sets, so we have negative 1 over 3 to 1 over 3 as the region where the other binomial is valid. And then we have the other region as minus half to half. So which one is the intersection? So you want values of x that will be in both sets, this set and the other set. So you now see that it's that region there. So therefore, the expansion is valid for minus 1 over 3 less than x less than 1 over 3, or we can say absolute value of x less than 1 over 3. That's the end of that example. Okay. Was that clear? You're not talking. Any questions?
It's clear, madam.
Yes, madam.
Any questions? Do we have questions? No. Okay. So we are ending our class. Now, in the tutorial sheet, you have that question 3 there. Did you all go through it? Tutorial sheet for binomial. Okay, you went through it with the tutor, so I don't think we have any problems anywhere. So the question is just like a teaser. Tutorial sheet number, question 3, tutorial sheet 10. You have n choose 0. Show that this is equal to 2 to the power n. So how did we handle this? How was it handled? No one is responding. Okay, so you can start with the right hand side, which is equal to 2 to the power n. Then 2 is the same as 1 plus 1. So you're saying 1 plus 1 to the power n. And then using the binomial theorem, we know we can take one of the ones as A, the other one as B. So we are simply saying that 1 plus 1 to the power n is equal to n, choose 0, 1 to the power n, plus n, choose 1, 1 to the power n minus 1, times 1, plus n, choose 2, 1 to the power n minus 2, times 1 to the power 2. This goes on and on until we reach n, choose n minus 1, 1 to the power n, 1 to the power 1, times 1 to the power n minus 1. Then finally, n, choose n, times 1 to the power n. So when you look at that, whenever you raise 1 to any power, you still get 1 back. And so you get back what's on the left-hand side. So it just gives you back n, choose 0, plus n, choose 1.
Madam, I have a question.
Yes?
What if it was 2 raised to the n minus 2?
2 raised to the power?
N minus 2.
2 to the power n minus 2, like that?
No, as in the 2 is also a base, not a power, madam.
So to the you are saying 2 to the power n, then minus 2. Is that what you're
Yes.
saying? So that one is equal to
Yes,
what?
madam.
They are saying it's equal to what?
Is equal to the right hand side of this same question.
It can't be. Can it? Can those two be equal? We have already shown that 2 to the power n is equal to the other one. So if you put minus 2, what will happen? Is that the question? That's how it was?
Let me read it out, madam. It is equal to n choose 1 plus n choose 2.
So you're saying it's n choose 1. Okay, let me
Equal,
clear this first. So you're saying n choose 1 plus n choose 2
n choose 2
plus
plus n choose 3 plus dot 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 plus n choose n minus 1.
n choose n minus 1. Yes?
Yes.
Is equal
It
to?
is equal to the 2 to the n minus 2.
Yeah, this one now would make sense. So you know, we've already proved that n choose 0 plus n choose 2 plus n choose 3 plus n choose n minus 1 plus n choose n is equal to 2 to the power 2. Not so. So you see that they are not the same.
Yes, they are not the same.
Yes. So now, do you know where that negative 2 is coming from?
No.
Oh, sorry, this is 2 to the power n. Because what is n choose 0? What did we find yesterday?
N choose 0 is equal to 1.
It's equal to 1. And n choose n is equal to?
N choose 1.
1. So we're simply saying that
1.
oh, I left out the n choose 1 here. Okay, I can do that. N choose 2 there. So we are simply saying that, so if n choose 0 is 1, so we're saying 1 plus n choose 1 plus n choose 2 plus n choose n minus 1 plus, you know, n choose n is 1 is equal to 2 to the power n. Not so?
1.
So now when you transpose 1 plus
Yes.
1 is 2, take it to the other side, will give you what you had.
Okay.
Yes, yes.
Okay,
Okay.
thank you, madam.
Okay, you're welcome. So we are calling it a day. So we'll meet after the quiz to start looking at transcendental functions. Okay? So the quiz is on Wednesday, meaning that maybe Thursday, Friday, I can start teaching the other topic. Bye.
Madam,
Bye.
when are we going to get the other details on the quiz?
Which other details?
The time that is going to open and the
But
duration.
it will be put, it will come together with the what? The quiz itself. That's what we usually do.
When is the quiz this Wednesday?
Yes, yes, after tomorrow.
Okay.
So tentatively, you know that it's taking place on Wednesday. So you prepare for Wednesday. Then I think we'll put it at 14, like last time, like the previous one. Okay. Have a good evening. Go and cook the shima and whatever else you are
Thank you,
cooking.
man.
Okay, okay, bye.
Thank you. We've eaten.
You've already eaten.
Yes, we eat early
Oh, okay, that's good.
for digestion purposes.
Yeah, that's good. It's not good to eat very late. Bye-bye.